A 2,000-pound bomb is dropping toward open water in the Gulf of Oman, not at a ship, at an empty patch of ocean, roughly 30 feet off the port side of an Iranian supply vessel, attempting to run the blockade. The bomb isn't aimed at the deck, it's aimed at what's underneath. 3 seconds before impact, the seeker in its nose does something no gravity bomb in history was ever designed to do. It steers away from the steel and toward the waterline. What unfolds in the next 1.4 seconds is the reason the United States Air Force no longer needs a submarine to break a ship in half. And the whole thing costs less than a new pickup truck. The United States is running a full naval blockade of every Iranian port. Every vessel entering or leaving Iranian waters is subject to interception. This isn't a one-day strike. It's an open-ended siege, sustained until Tehran's economy collapses or its government comes to the table. That means ships have to be stopped. Ships that refuse get disabled. Ships that resist get sunk. Not once, not 10 times. Every day, every week, for however long it takes. Here's the problem nobody's talking about. Sinking ships is expensive. A Mark 48 heavyweight torpedo runs $4 million. A long-range anti-ship missile costs over $3 million. The average Iranian supply vessel trying to slip through the blockade is worth less than $500,000. You're spending $4 million to sink a $500,000 ship. Do that 5 times a week, and you've burned through $65 million in ammunition inside a single month, on targets worth less than $10 million combined. That ratio doesn't sustain a blockade, it bankrupts one. The United States Air Force solved this problem, not with a new missile, not with a submarine. With a 2,000-pound bomb that already exists in warehouses by the tens of thousands, fitted with a seeker that costs less than a mid-range sedan. But before you can understand the solution, you need to understand why the old approach was never going to work at Hormuz. And the answer isn't about technology, it's about water. Every weapon the United States has used to sink enemy ships over the past 40 years was built for a completely different war. Torpedoes were engineered for deep water engagements against Soviet submarines. Anti-ship missiles were designed to kill heavily defended warships loaded with radar and countermeasures. These are precision instruments built for high-value targets. A blockade isn't a high-value target problem. It's a volume problem. Dozens of vessels, cargo ships, tankers, fishing boats repurposed as supply runners, attempting to cross the line every single week, most of them worth less than the weapon it takes to stop them. The traditional options fall apart under that math. A Virginia-class submarine carries roughly 25 torpedoes. At $4 million each, that's $100 million of ammunition sitting inside a $3.4 billion hull. To reload, the submarine has to return to port, a round trip measured in weeks. And operating a submarine in the shallow, mine-seeded waters near the Strait of Hormuz is a calculated risk no fleet commander takes lightly. The missile option is no better. Using a weapon designed to defeat radar-equipped warships against an unarmed cargo vessel is like dispatching a Formula One car to deliver groceries. It works, but the economics are obscene. The blockade needed a weapon that was cheap, accurate, and lethal enough to sink a ship in a single pass. That weapon didn't exist 5 years ago. It exists now. And the physics behind it starts with a question most people get wrong. What actually sinks a ship? The answer isn't fire. It isn't a hole in the hull. It's something far more violent, and it happens underneath. Drop a 2,000-pound bomb onto the deck of a cargo ship. It punches through the steel plate, detonates inside the superstructure, and turns the upper decks into a furnace. The crew is gone. The bridge is destroyed. Fire tears through every compartment above the waterline. The ship is still floating. Below the waterline, the hull is intact. Watertight compartments are sealed. The structural keel, the backbone running the entire length of the vessel, is untouched. A large ship can absorb 2 or 3 direct hits to the deck and drift for hours, sometimes days, before flooding slowly pulls it under. This is what Hollywood consistently gets wrong. Explosions above the waterline destroy equipment and kill crews. They do not sink ships. To sink a ship reliably, quickly, with a single weapon, you have to attack from below. This is exactly what a torpedo does. The Mark 48 doesn't strike the hull from the side. It detonates directly underneath the keel. Water is incompressible. When the warhead goes off beneath the ship, the shockwave doesn't dissipate outward the way it would in open air. It transmits upward, all of it, straight into the bottom of the hull. 3 things happen in sequence. First, the shockwave lifts the midsection of the ship out of the water. Second, the expanding gas bubble creates a void, a cavity of nothing, directly beneath the keel. Third, the bubble collapses. The midsection drops into that void. The bow and stern are still supported by water on either side. The ship's own weight, tens of thousands of tons, does the rest. The keel snaps. The ship breaks in half. Same explosive force. Above the deck, you get a fire. Below the keel, you get a broken spine. Position is everything. This is precisely why torpedoes are so expensive. Engineering a weapon that can navigate to exactly the right spot beneath a moving ship, at the right depth, at the right angle, is a $4 million engineering problem. The Air Force asked a different question. What if the weapon didn't have to swim? What if it could fall? The answer to that question already has a name, and it's already operational. QuickSink is not a new bomb. It's an old bomb with new eyes. Start with a GBU-31 Joint Direct Attack munition, a 2,000-pound gravity bomb guided by GPS and inertial navigation. The Air Force has tens of thousands of them in inventory. The basic kit costs around $25,000. It's been the backbone of precision strike since the late 1990s. Now bolt a seeker onto the nose. Not a radar seeker, not a laser designator. A multi-mode sensor built on the Weapon Open Systems architecture. A modular plug-and-play framework that accepts targeting components from multiple manufacturers. The seeker detects, classifies, and tracks a surface vessel autonomously. Target cost at serial production, $50,000. Total system cost at scale, approximately $70,000. Against a $4 million torpedo, the ratio is 1 to 57. Here's how it works. The bomb releases from the aircraft, an F-15E Strike Eagle, a B-2 Spirit, any platform cleared to carry JDAM. GPS guides it to the target area. As it descends, the seeker activates, locks onto the ship, and calculates an impact point not on the deck, but at the waterline adjacent to the hull. In the terminal phase, the bomb executes a sharp trajectory correction, punching through the ocean surface beside the ship's keel. The nose cone is specifically redesigned to prevent skipping. At high velocity, water behaves like concrete. A conventional bomb hitting the surface at a shallow angle would ricochet and miss entirely. QuickSink's nose geometry ensures penetration. The bomb enters the water, positions itself beneath the hull, and detonates. From that point, the physics is identical to a torpedo. Shockwave, bubble, collapse, keel break. The ship doesn't know the difference. QuickSink doesn't build a new bomb. It gives the old bomb a diving lesson. And this isn't theoretical. In 2022, an F-15E from the 53rd Test and Evaluation Wing dropped a QuickSink weapon in the Gulf of Mexico. The target vessel broke apart and sank in minutes. In July 2024, during RIMPAC, a B-2 Spirit employed QuickSink against the ex-USS Tarawa, a 40,000-ton amphibious assault ship, 820 feet long. The weapon worked, the ship went down, the physics is proven, the cost is solved. Now the bomb has eyes, it needs a kill chain. That chain has 4 links, 2 that watch, and 2 that strike. High above the Gulf, the E-7 Wedgetail stares down at the ocean. Its MESA radar, an active electronically scanned array mounted atop a Boeing 737, doesn't rotate mechanically the way the old E-3 Sentry's dish does. It steers its beam electronically. The E-3 completes a full scan every 10 seconds. The E-7 can update a sector of interest in 3. A fast attack craft running at 50 knots covers less than 80 meters in that window. The Wedgetail never loses it. Lower and slower, the MQ-9B Sea Guardian fills the gaps radar can't reach. 30-plus hours of continuous flight. Electro-optical and infrared sensors that can read hull markings from altitude. It doesn't just find targets, it confirms them, verifying whether a vessel is carrying concealed weapons, military cargo, or an IRGC boarding crew. The Wedgetail sees everything. The Sea Guardian identifies what matters. Both feed data into the Joint All-Domain Command and Control Network. The system processes the feed, calculates targeting solutions, and pushes coordinates directly into the cockpit of the strike aircraft. The delay between detection and weapons release is measured in seconds, not minutes, then the strike. The blockade divides the ocean into 2 zones, and each zone belongs to a different aircraft. The F-15E Strike Eagle owns the open water, the Gulf of Oman, beyond the reach of Iran's coastal air defenses. The Strike Eagle carries 4 or more QuickSink weapons per sortie, orbiting visibly above the shipping lanes. Its presence alone is a message. Warnings go out on Channel 16. A loaded fighter circling overhead is the last communication most captains need. But when warnings fail and the vessel keeps running, the Strike Eagle delivers an argument that ends below the waterline. The B-2 Spirit owns the coastline. Near Bandar Abbas, inside the engagement envelopes of Iran's Bavar 373 and S-300 surface-to-air missile batteries, no conventional fighter survives. The B-2 doesn't need to survive detection. It avoids it entirely. Stealth geometry carries it through radar coverage unannounced. It reaches supply vessels sheltering near port, vessels whose captains believe proximity to shore-based air defenses makes them safe, and delivers QuickSink from directly above. Iran sees no aircraft on radar, hears no engine noise. The ship simply breaks apart and sinks, one visible, one invisible, both carrying the same $70,000 weapon. The F-15E enforces with presence, the B-2 enforces with absence. Together, they leave no gap in the blockade line. One technical limitation worth acknowledging. QuickSink has no electronic countermeasure suppression capability. Against an Iranian frigate running active radar and a close-in weapon system, the bomb is vulnerable during terminal descent. That's where a long-range anti-ship missile earns its price tag, suppressing the ship's defenses from standoff range, clearing the airspace so QuickSink can finish the job uncontested. The expensive weapon blinds the target. The cheap weapon breaks its spine. Now here's the question that ties all of this together. If the Air Force can sink ships with gravity bombs and a data link, what is the submarine still doing here? QuickSink doesn't replace the submarine, it liberates it. Before this weapon existed, a Virginia-class attack boat had to do everything. Hunt surface vessels, track Iranian Kilo-class submarines hiding below the thermocline, collect intelligence, launch Tomahawk strikes against land targets, 4 missions, 1 hull. A mixed magazine shared between every target on the priority list, no capacity to spare. QuickSink strips the first mission entirely. The Air Force now owns the surface. The F-15E clears the open water. The B-2 clears the coast. The submarine pulls back to the thermal layer and refocuses on the one thing only it can do: track what's underneath. Because the submarine threat doesn't end with a handful of hulls on the seabed. Acoustic intelligence collected in the first 72 hours of the blockade has already detected signatures that don't belong to any Iranian platform. Someone else is watching, hunting that quietly, tracking without being tracked. That's a mission only one platform in the world can execute, and that platform is now free to focus on nothing else. The Air Force takes the surface, the Navy takes the depths. The blockade has no seam. And notice the reversal. Water, the antagonist of this entire story, the substance that makes bombs skip, that shields hulls, that turns shockwaves into unsolvable physics problems, is the very reason QuickSink works. Water is incompressible. That's why it defeats conventional deck strikes. And that exact same property is what transmits 100% of the shockwave straight into the keel. The enemy became the weapon. QuickSink proved that a $70,000 bomb dropped from a stealth bomber can do the job of a $4 million torpedo launched from a $3 billion submarine. The physics is settled. The tests are done. The question now isn't about the weapon. It's about everyone else watching. If the Air Force can sink fleets with cheap gravity bombs and a data link, what does that mean for every Navy in the world that built its entire doctrine around the assumption that killing ships requires expensive missiles and expensive platforms? That assumption just hit the water, and it didn't float.